In this video, we are going to learn about operations on signals. So the first operation on signal is time shifting. If x of t, if we perform operation like x of t minus t0, then it will be the positive shift or the right shift. Okay, the signal in the plotted graph will shift to the right. You can see here. Suppose if the x of t, when we perform the operation like x of t plus t naught, then it will move to the left shift or negative shift. Okay, left shift. Now you can see the graph here. Suppose if the x of t is like this, the interval is -2 to +2, means the duration of time is 4, right? If you perform the t minus 2, which means the positive shift, the signal will shift to the like right side. Then here you can see like 0 to 4 it will move. Same again, the 4 units of time will be the same. If you perform the operation like x of like t plus 2, then it will move to the left, like 0 to -4 will be the again 4 units of duration will be the same. Now t naught, it may be the integer or anything. N must be integer. What is this mean by the n means? It is for the discrete value, right? The discrete time signal, the n must be the integer. Here time period 4 remains same in the any of the shift. Okay, this is how the time shifting will be. Now let us see time scaling operation. Here in this operation, time period also changes. In the last operation like time shifting, there is a fixed form of time period, but here time period also changes in this time scaling. Suppose x of t, like if we perform operation like x of at, here in the scaling, here the a will add to the t. Okay, in the last operation it is in form of subtraction or addition. Here it is a multiplication or division. Okay, in this scaling, okay, a is always positive. A is always positive means greater than 0. Okay, if a greater than 1, it is like a comparison of signal. If a less than 1, expansion of signal. Greater than 0, always it is a positive value, but if it is a greater than 1, means whatever this thing, right? A, if it is greater than 1 means the signal will be compressed. If it is a less than 1 means like 0.5, 0.2, which are the values less than 1 and greater than 0, right? Then the signal will be expand. See here you can see same -2 to 2, let it be the graph. If it is the a equals to 2 means you need to divide. Okay, so if a is 2 means it is a 2t. For the time it is like +2 by 2 -2 by 2 means it will lies between -1 and 1 only. See here the time period 4 to 2 units it is changing. Okay, now if it is a 1 by 2 means which is a less than 1. Now from the theory the signal should expand. Now let us see by the plotted graph. Okay, t by 2, right? So in terms of t, you need to multiply, like -2 by 1 by 2, -2 by 1 by 2 means it is like -2 into 2, right? Which is like -4. Same way, if it is a +2 means it is a +4. Means -4 to 4, the graph will expand. Okay, so -4 to 4 means it is like 8 units of time. Now here For the value greater than 1, it will be compressing. If it is less than 1 means it is expanding. Suppose if it is a unit step signal, this won't work. Okay, if you perform on unit step signal, if the graphs are showing like this, the time scaling property, if you apply also, there will be no change in unit step signal. I hope you got the idea on time scaling property. Now the next operation is time reversal operation. So in this operation, if you perform means the plotted graph will mirror of the signal. Like the condition is x of t will change to x of minus t if you apply the time reversal. So x of t is like this, like minus 3 to 2, the time will be, the graph is like this. If you apply the x of minus t, now if you apply the time reversal property, then the plotted graph will change to like this, like the signal will change to minus 3 to 2 in this manner. Okay, this is how the time reversal property will be. For better understanding, let us take one example. Let us take example like x of t, let it be t plus 1. Okay, then x of minus t will be the minus t plus 1. Right, let us take few samples. Let us take first x of t, this is t, right? Minus 1, 0, 1. Then t plus 1 means like minus 1 plus 1 will be the 0. It is a 1 right here, 1. 1 plus 1, 2. So this is how the graph will be. Now x of minus t will be the minus t plus 1, right? Same, x of minus t, t, 0, 1, let us take. So minus 1 minus into minus plus, or you can like this. So it is like the 2, right? For the 0 it will be the 1. For the 1 it is like the 0, right? So see here, the graph will be the mirror graph, right? I hope you got the idea on time reversal. Now let us go for the amplitude scaling property. So just now we have seen about time scaling property. Now let us see for the amplitude scaling. So if it is a y of t, let us take a y of t, x of t. So the scale version of y of t is like this, like y of t is c x of t, like scale version of signal, and of the x of t will be the y of t. What is the scaling factor? C will be the scaling factor. Like this the amplitude scaling will be. Let us go for the one example, you will get the detailed idea on this. Suppose if x of t is 4 cos t, y of t is 2x of t means, then y of t will be the 8 cos t. See, for the 4 cos t, we are getting 8 cos t means some kind of the improvement, means that improvement is known as the scaling here, known as the amplitude scaling. But if the graph plotted like this, it is in the lies in between 4 minus 4, then the scaling version of this like same graph, but here 8 to minus 8. Okay, this is how the amplitude scale will be. Okay, now let us go for signal addition and signal suppression operation. Let us take first signal as x1 of t, and it is the graph like this. The x2 graph is like this. Now suppose the x3 is addition of x1 and x2, means the graph will be lies like this, like at the 0 it is like the 2 and 1, 2 and 0, right? So the graph is plotted at 2, like 2 plus 0, which is like 2. For the 1 unit at the time t equals to 1, it is like 2, and it is like the 1, 2 plus 1, which is like 3. Again same at the 1, from 2 to 1 it is followed, right? Like again it is a 1, and 1, which is like the 2. Again it is falling. From 1 to 3, from 1 to 3, it is like the same graph. 1 unit and 1 unit, 1 plus 1, 2 units. Okay, you can plot like this, you can do. Now for the x of 4, like x of 4 will be the subtraction of these two signals. Then it is like 2 minus 0, which is like 2. For at the 1, it is like 2 minus 1, which is like 1. Again it is falling, right? 1 minus 1, which is like 0. See, from 1 to 0 it is falling. You can do so, you will get this graph. This is how the signal addition and subtraction operations will be. Again, let us go for the signal multiplication also. In the signal multiplication, let us take the x1 like this, x2 graph like this. So when you plot the x3 in terms of multiplication of x1 and x2, like 2 into 1, 2, again 2 into 1, 2, again it is falling, right? Like at the 1 into 1, which will be the 1. When you do so, you will get this graph. Okay, this is how the operations on signals will be. I hope you got the idea on how the operation are performing on signals. If you learned anything in this video, please do a like and support by subscribing. Thank you. Thanks for watching this.